Okay, and then do share screen. Okay, I will do whiteboard first. Okay, so last week, you remember we discussed application, is it, using stack. So stack application. And the app we discussed is about postfix expression evaluation. Then we discussed the algorithm and the code. Okay, so postfix expression, you remember there is no parenthesis, is it? And it's the pattern is you have two numbers followed by an operator, is it? So that's postfix expression. And there is another name for postfix. It's called, yeah, last class for some reason that's name just flipped out. The after class I remember back what the name is. It's called reverse Polish notation. Oh, notation. So the abbreviation is RPN. Okay, so in computer science, or maybe in math also, okay. If you see RPN, reverse Polish notation, it means postfix expression. And why we say it's Polish, and you know a lot of mathematician innovations is by Polish mathematician. So this is also by one of the Polish mathematician. So that's why we call reverse Polish notation, okay, RPM. Okay, we already know the algorithm. Hold on, I need to get, okay. I already clicked that. Okay, and then, so that's regarding postfix, is it? And the regular arithmetic expression. Expression, is it? And with parentheses, is it? Because parentheses then give you the preference of when you do the evaluation. Is there something like the 3 times 6, then plus 5 times 7 minus 3, like this kind of expressions. It's an arithmetic expression. We all quite familiar with it, is it? And there's also a name, we call it infix expression. Okay, so it's in order, kind of like the idea. Okay, later on in our, if we have time this week, no, this semester, we may also see, okay, pre-order, in order, post-order, those kind of concepts. So similar pattern we follow. So that's why we call this as the infix expression, okay? And for infix expression, it has parentheses, is it? And we also follow the order, is it? So multiplication has a higher precedence, is it, than plus? Is it when we don't use the parentheses and we follow this rule? Is it? So, okay, so anyway, that's an infix expression. Okay, let me copy down this, then we are going to start to discuss. Okay, why I cannot write over here? 3 times 6. Oh, let's see. Let me just clear everything out, okay? Because otherwise I may not have enough space to rewrite everything. So let's repeat this express 3 times 6, and then plus 5, then times 7 minus 3. Is it? So this is our infix expression. Is it? And for postfix evaluation, generally speaking, it's faster. It's more efficient. So that's why we use postfix, because there is no parentheses. It's pretty faster. Okay, And then the question is there some way that we can convert infix to postfix? Is it to postfix and then calculate? Yeah. Of course, there is also algorithm to do it. Is it? And visually, we can also do infix to postfix expression. Is
I have
it?
a question.
Yeah, please.
So I guess we can do that only if our numbers are one digit, right?
No, multiple digit. It doesn't matter because, okay, very good question, okay. And generally speaking, later on, we are going to also cover that, okay, because you remember last class, we also explained, is it, suppose you create an application, it's a text field. Is it, this is a text field, we learned. And whatever you have in this text field, it's a string. Is it? It's a string. But of course, we need to have space. Is it? So separate. And you can also have like multiple numbers, digits. Is it? It doesn't matter. But this is a complete string. Is it? And if you call string split method, is it? You can get each number out. Is it? But it's still a string. Is it? So this is string. And then, yeah, because this is string and we can convert. Is it?
So you add string to the stack, right? You don't add one character, you add whole string to the stack, right?
Yeah, the whole string is a string. It's the input. This has nothing to do with the stack yet. Okay. So, and then you have this number, string number, as if this is a string. And then we can convert it to number. Is it, I remember we have that parse int. Is it those kind of function? Anyway, you can have function to convert it. Is it convert string to integer? Is it, you can also convert integer back to string. Is it? Yeah, so that's the idea, okay. Okay, so assuming right now when we discuss algorithm, we assuming that a number is already converted, okay. So it's already number. We just think about a number, okay. So right now, let me get this. I need a little bit of more space here, okay. And draw, okay. And now I want to discuss how to convert infix to postfix, is it? And basically over here, we can also use stack. Use a stack. Okay, so let's see, how do we do it? The algorithm, I may need more space, sorry. Okay, okay, erase. Hold on, let me, if there's a bigger brush, that'll be good. Save a lot of time. Okay, then let's see. So similar as what we do postfix evaluation, okay, we are going to do scan from left of the expression, is it? And how do we do the tokenization? As we already explained. So this is, you can, for string, you can just call the split, then you can get each word out, is it? Okay, so you get this is called a token. So we scan token, is it? Okay, so you get this token and you determine if it is a number or a digit, is it? And we can see this is number. So if it is a number, then here we have its corresponding postfix expression. Okay, we just put to its postfix expression, and then we move on. Okay, this is an operator. So if it is an operator, so this time our stack change. Okay, so this is our stack. So the stack this time holds operator. Not like last week we discussed postfix evaluation, the stack holds numbers. Is it? This holds operator. So it is an operator, and at this moment the stack is empty. So there is nothing to compare. So I just drop it to the stack. Okay. And next is a number. If it's a number, I append it to my postfix expression. Okay. So I add it to 6. And next is plus. Plus is an operator, okay? So if it is an operator and your stack is not empty, okay? So if token is operator and stack is not empty, then here what you need to do is you need to compare, okay? So basically there is a loop. And within the loop, you need to compare the top of the stack with token. Okay, and if token doesn't have higher precedence, okay, then what you need to do is you pop top operator out of stack, append it to postfix expression. Okay, so let's see. We have plus. So this is our token. Then I need to compare with the top of the stack. Top of stack is multiplication. And this token doesn't have a higher precedence. Is it? Because multiplication is ahead of plus. So I need to pop this out, apply it to postfix expression. And you need to keep doing, okay? So this is a loop here. Keep doing until it doesn't meet this condition, until the token have a higher precedence, then you stop, okay? So right now, because the stack is already empty, is it? So what you need to do is you push the token back to stack. Okay, so out of the loop, so I run out of space here. Okay, so this is end of loop. So end of loop, I push token to stack. Okay, and let's continue. Next is 5. If it is 5, what is our rule? Who still remember? If it is 5, what is the rule? For this number 5, anyone knows? Maybe I didn't, hold on, let me check.
Add it to expression.
Yeah, very good. So add it to the postfix expression. Okay. Okay, so this is going to be our first question. So if token is number. Okay, so quiz question. So quiz 1 question. What do we do? If token is number, what do? We add it to postfix expression, is it? So you should see add token to postfix expression. Okay, so that's the answer. You can send your answer to the quiz, okay? And then let's continue, okay? Next is multiplication. So now the token is multiplication. Multiplication, we said you need to compare the token to the top of the stack. And this token has higher, so it is higher than top of stack. Is it? Because it's higher than top of stack, so no loop in this case. So it will not go inside the loop, is it? So what it's going to do is you just push that token to the stack, okay? Because you compared, is it? Okay, next. This time we have a left parenthesis. Left parenthesis, it's not a number, it's not an operator, is it? So what should we do? Okay, so let me erase. Okay, so this is a left parenthesis. So for the left parenthesis, it's if token is left parenthesis, you just push token to stack. Okay, so we just push it to the stack. Okay, so this is our second question. Okay, second question. If token is left parenthesis, what should we do? You can send your answer to our chat. This is the second quiz question. And then let's continue. Next is 7. If it is 7, what should we do? What should I do if it is 7? 7, it's number, is it? Number, I just add it to the postfix, okay? And next, the token is minus sign. And when token is an operator, what do you need to do? You need to compare with the top of the stack. But the top of stack is not an operator, is it? So there is no precedence comparison. So what you need to do is you then just push it to stack. Okay, because if only the top of the stack is an operator and it has a higher precedence, is it? Then you pop it out. But this case, the top is not an operator, so you just push it to stack. So you directly run to this step in your algorithm, is it? Okay, next is 3. 3 is number, so I need to add it to postfix. Okay, next token is a right parenthesis, is it? So if token is a right parenthesis, what should we do? Okay, and I will write it here, okay, for the algorithm. So if token is right parenthesis, here is the rule, okay, it's a right parenthesis, you pop the top of the stack, or you pop the top of the stack out. Okay, so I pop the minus out. And then I need to append it to my postfix expression. So I append it to postfix expression, okay? So if your token is right parenthesis, then you need to pop top out. And pop top out, if top is operator you append to postfix. Okay, I appended to postfix. And when you will stop this pop operation, you need to keep popping until you see the left parenthesis. Okay, so this is going to be in a loop. Okay, so while what? While top is not the left parenthesis, you need to keep doing this. Okay, and if it is a left parenthesis, then what you do? You just pop it and you drop it. Is it because in postfix there is no parenthesis? Okay, and now I continue and I need to stop because it's the end of the expression. At the end, you just clean everything out from the stack. So you pop everything out of the stack and append it to the postfix. So I pop multiplication out, I pop the plus out. And now the stack is empty. So this is going to be your final postfix expression. Okay, so that's this algorithm. How do we convert infix to postfix? Okay, so the third quiz question. The third quiz question is: if token is right parenthesis, what should we do? So you just say, okay, pop out and append it to postfix in a loop. Okay, can you send your chat answer to the quiz answer to the chat? So the third one is, if token is right parenthesis, then your answer should be, okay, you can either write as while top is not left parenthesis, I pop out and append it to postfix, okay. So while top is not left parenthesis, you pop it out and append it to postfix expression. Okay, so this is the algorithm. And let's get to another one for exercise, okay. We can work together for, did everyone send out your answer to the quiz? Okay, next one, let me find a one that's a little bit of so that we can do a quick exercise, okay. Let me find a good example. Infix to postfix, okay. Let's see, I need to change this to drawing. Okay, let's see this one. We have parentheses, then we have 3 and plus 5, then right parentheses, multiplication, suppose 19, okay, and then minus 59, and then plus, right parentheses, and then plus, hold on. And then plus 6. Okay, so we have this infix expression, is it? So let's, I should just do clear all. So maybe let me just do clear all, it's too slow. Let me rewrite that expression, okay. This takes forever otherwise. Okay, it's 3, is it plus 5, parentheses times 19, is it? And minus 59, is it? And plus 6. Okay, so we have this infix. So let's convert it to postfix, is it? So let's see how do we do it. So I'm start scanning. Is it? Anyone tell me what should I do? So how about I put postfix here, and I put my stack here. Okay, the first token is left parenthesis. What should I do? Who still remember?
Push to stack.
Very good. Push it to stack. Next one, left parenthesis.
Also stack.
Also push it to very good. Number 3.
Expression.
Add appended to expression. Plus. Next one is plus operator. Push it to stack. Very good. Number.
Expression.
Push it, add appended to the expression. Very good. Right parenthesis. Right.
Pop the top.
Yeah, pop out the top. Appended to the postfix. Then.
Then your loop hits the left parenthesis.
Yeah, so
until you keep popping. Is that remember here? Keep popping. Until what? Until matching left parenthesis. Is it? You need to get this out. And that's it. Is it? Next, multiplication. What should we do? Push it to stack. Yeah, very good. And oh no, next should be left parenthesis again. So left parenthesis, push it to stack. Yeah. Next one's 9 number.
I thought that was 19.
Oh, yeah, you're right. I'm sorry. Yeah, it should be 19. Thank you. It should be 19. Okay. 19. Very good. Okay. So it's after multiply, it's 19. 19, I push it to the, I append it to the postfix expression, is it? And the next, minus sign, operator.
Stack.
You compare with the top of this. If it doesn't have higher precedence, does it have higher precedence?
Minus
It
has
doesn't.
lower.
So you need to do what? You need to pop this out.
Pop from top and then push the minus.
Yeah, pop it out, append it to postfix, and you keep doing. Is it? But there is nothing until you see the left parenthesis. But there is no precedence between minus and the left parenthesis. Is it? So that's why you add it to the stack. Is it? Next one, 59. Number I appended to the postfix. Next is what? Right parenthesis, what should I do?
Pop back till you hit the
Pop out, appended to postfix until you find the left parenthesis. Is it? You pop it out and let it go. Is it? And next is what? Plus operator, push it to stack. Very good. Yeah. Next, number I appended to postfix. And now the end of the expression. After the end of the expression, what should I do? Get everything out and append it to postfix. Is it? So this is going to be your postfix expression. Okay. So that's the algorithm. And now you see the left and the right parentheses matching, is it? And how do we deal with it? Is it? You just have the left one in the stack, is it? And then you use the right one, then you can use the stack to find the matching one, is it? So basically, you know, like whenever we write our program, is it? Oh, you have the while loop, is it? And then you have the parentheses, is it? And then maybe in it you have another for loop, and then you have the matching curly brackets, is it? And then in it you have if, then you have the matching one, is it? Just think about our compiler, is it? How can it identify those kind of matching brackets, is it matching bracket, and also maybe you have an array int a, is it? And how can it identify, is it? So basically, after we learn infix, you can think about it, is it? If you use stack, you can kind of also deal with this issue, is it? So stack, you can see, yeah, it can be used also to kind of find of this kind of balancing expression, is it? Not just limited to arithmetic expression, and also like in programming language, is it? And also maybe a word, is it? A word you have footnote something, is it? And all sorts of like this category of things, is it? You can also deal with using a stack, is it? So that's the concept, okay? Okay, we get everything out, and then let me share screen to give you more idea, okay? So we know how to convert infix to postfix, is it? And we also did that example together. How do I move to next one? Oh, we already learned of this. Okay, so the next question, on my slides on our course website, if you want to practice more on the slides, I have more exercise there. Okay, so you can practice after class if you like. And generally speaking, we already learned infix and postfix, is it? So you can see that we can also kind of putting all of the together, is it? This is like at the beginning of the class, is it? One of the students asked, is it, how do we do the evaluation, is it? So the idea is it, you can enter some infix expression, is it? Basically, it's some string, is it? And then you can apply some infix to postfix application, is a program to let it run, is it? And you can generate a postfix expression, is it? Basically, you can store it in some file, is it? And then once you have that postfix expression, is it? And then we can conduct our postfix evaluation. Then we can have the result, is it? So now we can combine kind of everything together, is it? So that's the idea, how we get everything together. Okay, so let's see. Yeah, so over here it says you can read infix, is it? Either from keyboard or from like a text field or even from a file, is it? And then you can run the program and get the postfix, is it? Get the postfix expression. If you have an evaluation also in your application, then you can directly run evaluation of the postfix. Otherwise, you can store it somewhere, either like in some file, is it? And later on, get the file input and then do postfix evaluation, is it? So we can combine them together, okay? Okay, so that's the idea about infix to postfix, okay? So the next concept is, let's take a look. And the infix to postfix, the program, the Java program is on our course website, okay? And you can also read it after class. What next I want to show is about this concept, okay? So share screen. And we learned the stack. We learned the stack, is it? And I remember at the beginning of stack, I also asked you, is it, where else we saw the stack word? Is it, you remember previously when we learned objects, we also mentioned, okay, whenever you do new, that new object is stored at the heap. So here we have the concept of stack, is it? So basically, then let's see this program, okay. This is a pretty simple program. So in this program, we have our main method, is it? And you all know, is it? Every application's entry point is main, is it? And each application only has that single main, is it? Operating system uses this as the entry point to start your application, is it? And your application, okay, it runs main. And in here, okay, it doesn't matter, okay, so it just output something. And here we call method A, okay? And then your program, so basically your program runs, is it? Because program runs, execute, it's called execute instruction, is it? Why didn't? Oh, I forgot the color here. So it's execute instruction. So this is kind of like an instruction. It's going to be executed anyway. Then to run to this method, is it? So it will jump to this method. Is it jump to this method? Okay, so you have a main method is running, is it? And now you jump to this method. Okay, this method said, okay, I'm going to output, and then it got what? It called method B. Is it? Oh, then it needs to jump into method B. Is it? Method B simply to type something, and then it said, okay, I'm going to go to method C. Is it? But did you see this method haven't finished it? Not complete yet. Is it? So main not completed. Completed, not completed yet. So then the question is, okay, after you finish method C, why the program knows, okay, then I need to run the next instruction. Then I finish B, I needed to know, go back to method A. After I finish method A, I needed to, I know to go back to main. Is it? How can program know this? It's kind of this kind of concept like backtracking. So how do you do backtracking? Is it? So basically that's the beauty of the stack. Is it? We already see stack is one of the major benefit is stack is very helpful for backtracking. Okay, so let's see. So basically, previously we learned is that we have runtime stack. So in operating system, you have the concept of runtime stack. Is it? Runtime stack is, okay, the main method. So this method is going to be pushed to the stack. And at this point, you only have this main is active. So the main is in the stack and at the top of the stack, is it? And then you call method A. So it needed to run to method A. So then method A is going to be pushed to this runtime stack. And it is at the top running, is it? But then to see B, so then it get B to the stack. Is it? And B is the top, so B is running. And then say, oh, method C is at the top. So method C is at the top, and the method C just do something, just to like also do some print out, is it? But method C is at the top of the stack, is it? So you will get this out, is it? Okay, C related, we call it a activation record, okay? So it, anyway, it is a record. Regarding this method, a lot of information, because it also needed to keep track of its parameter, its local variable, its return address, is it? So activation record is going to be kept, okay, within. So what over here, the stack store is each method's activation record, is it? Okay, method C, is it? It's done, is it? Then you just pop it out, is it? Pop it out. Then you get method B is at the top, is it? And when you finish method B, then you get method A, is it? So that's how you can keep track of which is the most current method running, is it? And it can also bring you back to the previous method that you just interrupted, is it? Because you're going to jump into the next method, is it? So that's how we keep track. We use a runtime stack to keep track of all of the method call, is it? So this kind of idea is, we call it backtracking. So backtracking, and also it's quite useful as, suppose you have some maze, is it? So I'm not too good at some maze, and you try to go out of the maze, is it? And when you're in maze, you don't know when you run to this point, you should turn left or turn right, is it? So you can also use the stack concept. So each time you remember your previous turn, is it? And when you reach some place like the dead end, then you need to roll back to your previous turning point, is it? So backtrack can be used also for playing maze game, okay? And you can also apply this, like if you want to run to a real world maze, is it? You can also borrow this stack concept to keep track of your previous turning point so that you can roll back, is it? So we can see there are a lot of quite useful applications, is it? And also, I don't know if you all experience, like for computer, is it? You can also do rollback, is it? Rollback to some previous date, is it? Because the operating system keep updating, is it? And there is some function you can recover, is it? You can also do computer recovery, is it? Recovery is you can pick some rollback point, is it? To roll back. And that kind of concept is also kind of like, you can also kind of borrow like stack concept, is it? But of course, for computer recovery, you can pick a specific date, is it? So that's not just a stack concept, okay? So, but anyway, stack, we can see it's quite useful for reversing, for backtracking, etc., and also for the expressing the expression balance checking. Is it balance checking? Is it? So all of this kind of applications, okay. Okay, so this is the basic idea about runtime stack. So let's take a look. Okay, so method A, method B, then method C. Method C is quite simple. It's just say enter and exit of the method. Let's run this method. You can take a look, get some idea. Can you see the output? Can you all see this output?
Yes.
Okay, did you see it's enter main? And then said, okay, did you see enter main is here, but exit main is at the very end? And you have enter A, and you have the second last output is exit method A, is it? And then you have B, and the third last is B, is it? And the middle is all C. Is it? So you did see each method when you call it. It's not just in one time, it will run to the end of the termination of the method. So the method, it's not terminate. Is it? So it's not terminate just in one course, is it? So it's embedded with other method call, is it? Is it? So this shows our, so how a program can keep track of all of the method calls because of the runtime stack. Okay, so operating system has a stack. That specific stack is called runtime stack. And that runtime stack will keep track of, we call it an activation record of the method. Okay, of the method. And then you know when it is the method is interrupted and it can keep getting back, is it? And we can also see this case. It's going to be interesting because previously you remember we learned try catch, is it? So if an exception happens, what's going to happen, is it? So let's take a look at this case. So this time I update method C. In method C, I do some divide by 0, is it? So let's see what's going to happen. Then did you see here? Can you see the running result?
Yes.
Okay, very good. Okay, then did you see it said, okay, enter main. Then it said enter A, enter B, enter C, is it? And the exception occurs in C, is it? Occurs in C, is it? Occurs in C, but not caught in C, is it? In method C, is it? So you can see here is the calling stack, is it? It says, okay, here we have runtime call and the method C. Is it? Here is at arithmetic exception. Is it by 0? Is it? It has that exception. That exception, okay, first it goes to C, then it goes to B, then it goes to A, then it goes to main. Because if we go back, so here it gives the calling stack. Is it? The calling stack, is it? And we have exception here, is it? Okay, so let's see, we go back. So basically, if you take another close look, we don't have any try catch, is it? And in B, no try catch. In A, no try catch. In A, or in main, also no try catch, is it? So the exception, basically delta by who then? Delta by Java virtual machine in this case. Okay, and if you have some method that deals with that exception, catch that, then that method will be taken care of. Then you won't have this kind of trailing call back all the way to main. Is it all the way to main? So that's why we said a lot of time we recommend you do try catch. Is it? So that's a specific method. So anyway, so exception is caught at the right spot, is it? So that it won't be rolled back all the way to the main, and Java virtual machine is going to take care of, is it? Okay, so basically that's all of the materials for today. And before we close today's session, just a reminder, okay, this Thursday, we are going to have the third exam, okay, so please check the course website. And also, I need to fix the, oh, so Bradley, can you send it to the chat which quiz?
Yes.
A due date I need to up. Yeah. Any other question? Everything else is good, is it? Then